Have you ever noticed there's this one elegant curve that just seems to pop up everywhere? I mean, from massive engineering projects to the simple arc of a ball tossed in the air, it's a shape that's quietly running the show behind the scenes. Well, today, we're going to pull back the curtain and look at the math that makes it all tick. Okay, take a look at these satellite dishes. That curve? That's not just a cool design choice. It's a perfect parabola, and its whole job is to catch super faint signals from space and focus them all down to one single point. Without that precise mathematical shape, our global communication network, well, it just wouldn't work. Or think about sports. You know that beautiful, satisfying arc a basketball makes on its way to the hoop? Yep, that's another perfect parabola. Physicists, engineers, even athletes, they all use the math of this curve to figure out exactly where something's going to go. So it's in our technology, it's in our sports, it's everywhere. But what's the secret sauce? What's the underlying code that gives this one curve so much power? That's exactly what we're going to break down right now. All right, let's dive in. This U-shaped curve that we keep seeing has a name. It's called a parabola. And in the language of math, it's the picture, the graph, of something called a quadratic function. So here's the official definition, but don't let it look intimidating. While all the parts are important, the absolute star of the show is that ax squared term. That little squared is basically the DNA of the whole thing. It is the one special ingredient that guarantees you're going to get that signature U-shape every single time.
And here's the really cool part. Every parabola out there, no matter how complicated or stretched out it looks, is just a modified version of one really simple curve. So to understand all of them, we just have to start with the original, the basic blueprint.
And this is it, y equals x squared. The OG parabola. It doesn't get any simpler. All we're doing here is taking a number for x, squaring it to get y, and then plotting the point. You do that a few times and boom, you get this perfect symmetrical U-shape. This is our foundation. Every other parabola is just this one, but maybe shifted around, flipped over, or stretched out. Now, that general form we saw is useful, for sure. But there's another version that's way more intuitive. It's called vertex form. And honestly, you should think of it like a control panel for the parabola, letting you directly mess with that blue point we just saw. This is our control panel. Each of these letters, A, H, and K, is like a knob or a slider that we can play with. And by tweaking them, we can move, flip, and stretch that basic parabola and put it exactly where we need it to be. So let's see what each of these dials actually does.
Let's start with A. You could say A is the boss. If A is a positive number, the parabola opens upward, kind of like a smile. But if A is negative, it flips the whole thing upside down, more like a frown. The size of A also tells you if the curve is going to be wide or narrow.
Okay, next up is H. This is our horizontal slider. It moves the entire parabola left or right. Now here's the one kind of tricky part you have to remember. It's a little counterintuitive. A minus H in the formula actually shifts the curve to the right, and a plus would shift it left. A little weird, I know, but you'll get the hang of it. And our last dial, K, is way more straightforward. Thank goodness, it's our vertical slider. Positive K moves the whole thing up, and a negative K moves it down. Just a simple up and down elevator. So when we use H and K to slide the parabola around, what we're really doing is deciding the location of the single most important point on the entire curve. It's the point where everything turns around.
This critical spot is called the vertex. If the parabola opens up, the vertex is the absolute lowest point, the minimum. If it opens down, it's the absolute highest point, the maximum. And being able to find this vertex is the key to solving some really fascinating problems.
Okay, but that vertex control panel is great if you have the equation in that nice form. What happens when you don't? What if you're stuck with the more common general form? How are you supposed to find that all-important maximum or minimum point then? Luckily, there's a fantastic little formula for it. To find the x-coordinate of the vertex, which is h, you just calculate negative b divided by 2a. Super simple. Once you have that number, you just plug it back into the function to find its partner, the y-coordinate, k. That's all there is to it.
So why do we even care so much about finding this one point? Is it just a math exercise? Nope. It's a tool for optimization, for finding the absolute best possible outcome in a real-world situation. Let's look at a classic example.
All right, picture this. A farmer has exactly 80 feet of fencing. She wants to make a rectangular garden, and she's being clever by using an existing wall for one of the sides. So the big question is, how can she arrange that fence to get the biggest possible garden area?
This is an optimization problem, and the vertex is our solution.
Now, if we turn that word problem into a math equation, this is what we get. This function describes the area of our garden. Now look closely. See that a value? It's -2. It's negative. And what did we learn about negative a values? It means our parabola opens downward, which is great news. It means there is a maximum point, a peak area that she can achieve.
So let's use our formula. To find the vertex, we calculate -b divided by 2a. We plug in our numbers. That's -80 divided by 2 times -2. You run that calculation and what do you get? 20. That means 20 feet is the ideal length for the sides that will give her the maximum possible garden space.
And what is that maximum area? Well, we take our answer, 20 feet, plug it back into our area function, and we get the big payoff, 800 square feet. We just use the vertex to find the perfect dimensions for her garden. That's the power of the parabola in the real world.
So, let's do a quick recap. The picture of a quadratic function is always a parabola. We can control its shape and location with what we call the control panel form. The vertex is the most important point. It's either the ultimate maximum or the ultimate minimum. And we find that vertex to solve real-world problems, where we need to find the best possible outcome.
And this isn't just about gardens. This is about maximizing profit, minimizing costs, figuring out the trajectory of a rocket. The applications are pretty much endless. So the next time you see a curved bridge or a satellite dish, you'll know the powerful secret that's hiding in plain sight. So the only question left is, now that you know the code, what problems are you going to solve?